Hi, my name is Mudassir Sayed. I'm going to present my project massPike traffic analysis using VoltDB. VoltDB is a fast database designed specifically for streaming data. So we can have data coming in from mobile devices or sensors at a very high speed, and VoltDB can ingest it and process it in real time. So how does VoltDB do it? One interesting thing is that it runs completely in memory, so it doesn't need to read or write to the disk, so that increases its speed and performance. The second important feature is that when running on a cluster, VoltDB partitions not just the data in the table but also the stored procedures which interact with the data. So both the data and processing are distributed across the cluster. Now partitioning organizes the content of a database into table and separate uh, autonomous units, and the tables are partitions automatically based on the column that we specify, and then VoltDB takes care of partitioning the table, the data, and making sure that they are all concurrent. um, Stored procedures uh, are also partitions. So for queries that are run frequently, we can create stored procedures, and the stored procedures later define the query once, and then only change the input when we execute the procedure. So one important benefit of the stored procedures is that they are pre-compiled, and the VoltDB needs to know that what query we are running so that it can efficiently execute it across a cluster. So stored procedures give this benefit that they are pre-compiled and then they can be planned very efficiently. Uh, so let me move on to my application. So the application, as I said, I mean there are thousands of cars passing through the Easy Pass booths on massPike every day. We unfortunately don't have any live feeds available of the actual traffic, so I have an application that simulates traffic data. So here is a traffic simulator. It's an application that runs in Java. It runs as fast as it can, and it interacts. It basically inserts data into the tables which are on the VoltDB server. Uh, and then the VoltDB server also has stored procedures with process the data and create new views and entries in it. And then on the other side, we have a web host which also queries the server to obtain real-time statistics. So the VoltDB provides a JSON interface, which we use on the web host to basically query the data. So let me switch to my application. So here I have a virtual machine running on my Mac, and the first thing that I do is to start the web server so that we have a website. So I've started the web server, and then go look in my project, and I'm gonna just quickly show you the data definition. So here is my data definition. So you can see here is a table, a massPike exit table, which has information about all the exits, their name, their exit IDs, and the fare associated with them. This is a small table. So I mean, this is a small table which is not gonna change a lot. So we don't need to partition it. So it can be pretty much actually be replicated across nodes so that it's available for processing for each on each node. Now this is a transponders table, which has information about each transponder that's in a car and what the ID is, it's enabled or not, how much balance it has, and when it's going to be expiring, and then we have an activity table right here, which basically records each transaction. So as the car is going through the booth, we will create a new activity record for that car, for that transponder, and that exit ID. So these two tables gonna be huge. So like in my client application, I create about 300,000 transponders, and which run, and then I have about 10 million activity entries that I end up with at the end of my simulation. So these are huge, and they can be partitioned. So here I'm specifying how it's going to be partitioned. It's going to be partitioned on the transponder ID column. Then further down, let me just go down a bit. These are just views. These are standard SQL syntax to create views from the table so that I can query them. And then further down here, here are the stored procedures right here. You can see I have a syntax called create procedure from class procedures, and the procedure name is transwipe. So I have a Java code which is compiled along with the database, and it's loaded into the database. And here I am just declaring that there is a stored procedure called transwipe that we will load. And then further down here is an actual procedure that I'm just declaring and then defining here a replenish transponder stored procedure. Since it's a very simple procedure, I don't need to do a Java class on it. Okay, so let me exit from here and let me show you, and actually let me just start the application, and while it's loading I can start it. So I'm gonna start. So I'm gonna start it, and this script that we have actually starts the compilation. It compiles the stored procedures, and and then it's gonna start the client. So it's starting the client right now. So while it's starting, let's go back and let us look at some of the stored procedures. So here is one of the stored procedure called transwipe. So all the procedures extend a base class called volt procedure, which is right here. This is provided by VoltDB, and we need to basically um, extend this class. And basically this procedure creates a few small so this class creates a few functions for checking the balance. This is for charging the transponder, and this is for inserting an activity into the database. So here you can see the code. So I can, like, for example, just right here we can see that we first check the exit fare. Then we make sure that the transponder is a valid transponder ID. So now then after that we read the exit fare, and if the transponder is not disabled and it has available balance, then we charge it, and then we insert the activity the into the database. And let me now show you. Okay, so it's actually running, but let me just quickly show you the client side. So if I go to the client source benchmark. So this is a client application. It runs in it's written in Java. It basically calls the the jar library is provided by VoltDB to interact with the data and add data into it. And I'm gonna just, instead of just show you the loop where it continuously sit and adds data into the database. So here's an iterate function, which basically, as the name suggests, sits in a type loop and basically iterates. So we based on a random numbers will sometimes create a new transponder. We are just trying to replicate what happens in real world. Sometimes based on a random number, we will just replenish. We'll call the stored procedure replenish transponder to replenish the uh, the balance on a transponder. So now, and this part shows simulates what happens when the car is passing through the booth. So we read the transponder ID and then we read the exit ID. We just pick up randomly. Then we read the activity code. I'm gonna pick up a random number. If it is one, it means a car. Two means a truck. Three means it's an invalid. And then we will call that trans swipe procedure that I just showed you, and we pass it the transponder ID, we pass it the exit ID, and we pass it the activity code, meaning it's a car or a truck or an error code, and then that trans swipe stored procedure checks if the balance for the transponder is okay, if the transponder is valid, it's enabled, and if it is, then it will add the activity into the database. And let me exit from here. And then I'm going to show you what happens on the web interface side. So on the web interface side, we have a web index.html. Actually, I'm going to show you. So this is the code that's running on the web page, and it's actually pretty simple. We know what I want to show some statistics, right? So on the website, so we know that there is a stored procedure called get busiest exit in last minute, and I just call it using the provided sample, and there is a and then I get the response back. So there is and I get a response back, and I just defined a function called draw table, which I can use to process the data. So I'm getting the busiest exit in last minutes. I'm getting cars per second. I'm getting the money per minute, and these are the statistics I'm gonna show you. So let's go. So this is running. So let's go to the website. Let me just minimize that, and we gonna. Okay, so here is this running. So this is the cars per exiting per second code. So this is a chart, and it's showing the number of cars that's exiting per second. This is the transaction amount per second that's being generated, and further down here, this is the busiest exit within the last minute. So we are breaking it down as from each exit how many cars are passing, how many trucks are passing, and how many invalid entries are being done on that exit. And that just basically corresponds to each each of these things. So get busiest exits in last minute is basically this table here. Get cars per second is basically uh, this chart here, and get money per minute is basically this chart, the income earned chart here. Now once it's run, I can and in terms of the data being processed, we can do some ad hoc queries. So I can do select count stars from transponders, and you can see that I have about 548 transponders entries that are in my transponder database. And if I do select count star from activity, You can see right now I have about 6470000 uh, act, uh, uh, records in my activity table. So it runs pretty fast. We can see here is a performance transactions per second that VoltDB is providing, and you can see it's hovered between 20,000 and 15,000 transactions per second, and it's all running in one machine. And also realize that both server and the client are running on one machine. And if the client were to be running on a different machine, it would certainly increase uh, the throughput. So, just to conclude, I've talked about this. So in terms of the pros and cons, I found that VoltDB was pretty easy to install. It's fast in memory and it's scalable and it provides a ACID guarantee, so that all transactions are ACID guarantees, and partitioning details are taken care of. So once we specify the table and the column, we don't need to worry anymore about the partitioning and concurrency issues, and VoltDB takes care of it automatically. In terms of cons, the community edition is limited, so and there is no support for database snapshots and recovery. So if you want to do any decent work in it, you have to go with the enterprise edition. There is a 30-day trial, but after that, it has to be paid for. And we need to have a good understanding of how the schema design is going to work beforehand, because once we have the data in, and then if we were to go and make changes into our schema, uh, it may or may not be um, that fast anymore, because you're relying on a particular partitioning scheme. So if we go and change our schema and we don't have a good idea of how which tables are growing and how they're growing, we may lose our performance gains over time. Okay, so that's it. Thanks a lot.